Okay, so let's do another example here. Okay, and this one's of course complex. We're going to move a negative charge from here to here. Okay, notice that the negative charge is starting very close to another negative charge, and so you can see why maybe it's actually negative work. That is, that we don't have to do work, that it does work on us. Okay, because it wants to get away from that negative charge, and here maybe it's not as close to that one. I think is the major factor here. At the end of the day, our work is going to be the charge times the change in electrical potential. And so we're going from P to Q, right? So our change in electrical potential is going to be the final voltage minus the initial voltage. Now let's think about this. We're going from P to Q. So Q is our final, right? So VQ, the voltage at Q is our final, and our initial is the voltage at P. Okay? I'm very bad at these things. I tend to mess these up and get the sign wrong, so I'm just trying to be careful. So let's figure out the potential at P. Right? The potential at P is going to be the potential due to A plus the potential due to B. Right? So that's K times, let's see, A is negative 1.2 microcoulombs. Right? That's of course 1.2 times 10 to the minus 6th. K is 8.99 times 10 to the 9th. Right? And then our distance from P to A, this is the potential due to A, because that's A right there. It's 2 over 1 down, so 2 squared, 1 squared, right? So this column here is the potential due to A. This column will be B, right? So B is going to be K times 3.4 microcoulombs. Whoops. Square root of, and let's see, due to B. So we're looking at the potential at P due to charge B. So we are 1, 2, 3, 4, 5, and 2. Okay, let's just double check, okay? A is this charge, and it's 2 over 1 down, yep. B is that charge, yep, and it's 1, 2, 3, 4, 5, and 2, 5, and 2, okay. So now I'm going to type this into my calculator. I'm going to go 8.99 E9 times negative 1.2 E minus 6 divided by the square root of 2 squared plus 1 squared. Right arrow plus 8.99 E9 times 3.4 E minus 6 divided by the square root of 5 squared plus 2 squared. Enter. 851.4. All right, that's good. Positive 851.42 volts. That's the voltage at this point, right? Okay, so let's figure out the potential at Q. Okay, so again, due to A, it's going to be K times negative 1.2 microcoulombs. Again, 10 to the minus 6. Negative 1.2 times 10 to the minus 6. And then we're looking at Q, and we're looking at the charge A. Okay, so we are 1, 2 over, so 2 squared, and we are 1, 2, 3, 4, 5, 6 down. Let's just double check that. So we are 1, 2 over, 1, 2, 3, 4, 5, 6 down. Yep, it's that charge, and we're good. Okay. And then it's K due to B, right, is going to be K times positive 3.4 microcoulombs. And then our distance is 1, 2, 3, 4, 5 over. Plus, let's see how far down. 1, 2, 3 down. Okay, let's just double check this, right? So easy to make a mistake. So let's see, it's the B is this charge, yes. We are 1, 2, 3, 4, 5 over 1, 2, 3 down. Yep. All right, I'm ready to go. Now, what I'm doing is I'm just going up arrow, grabbing that last expression I did. All that's different is the denominator, right, between the two. All right, here we go. And that is 2 over and 6 down. All right. And I'm getting 3536.29. Okay, so now we got the volt. Right? This is the hardest part. Except now you're gonna mess up the next part. Right? So we got to be careful. So our change in voltage is the final voltage minus the initial voltage. You don't want to lose a half point for this, right? Okay, so final. Okay, so we're going from P to Q. Q is final, right? So it's 3536.29 minus our initial is 851.42. Our changes that would become more positive. So that guy minus this guy is positive 2684.86 volts, right? All right. And then finally, our work is equal to the charge times the change in potential. Right? So the charge that we moved is this negative 6.70 times 10 to the third minus third coulombs, right? And the potential is 2684.86, and that's positive, right? So I'm going to multiply by negative 6.7 e minus 3, and I get that the work is negative 17.9886. And now the hardest thing is, how do we write that with 3 sig figs? We're rounding to this spot. Clearly we round up, which makes it negative 18.0 joules. Clearly, unless it wasn't clear, and then it's not clear. Then I sort of insulted you. All right. Yeah? Okay, so again, so when you're doing these things, obviously, you mess this up or mess this up, that's just sad, right? But you should be able to do that, right? And then you got to figure out what's the final. It's always the final, right? Q is where we end up. P is where we started, right? Wait. Yes. Yeah. From P to Q, okay? So just be very careful about that. And then be careful about the charge, right? Because you can get that right, and then you forget the minus sign, and you're wrong again, okay? Now, whenever you've got a bunch of these, like, chances where you could make a plus-minus error, what you really want to do is you always want to make an even number of them, right? So if you flip the order of this, also forget that minus sign, right? Then you'd be back right. You'd be right again, okay? Yeah, I'm just joking. Is that funny? I can't tell. Are you laughing?